Hi my dear students, how are you all? I hope you all fine and safe at home. It is my pleasure to meet you again in this video session. This is M. Tamilvanan, your physics teacher from Bharathidhasanar Matric Higher Secondary School, Arakkonam. Today I am going to start a new topic from 10th standard Unit 2 Optics. The topics are refraction through a concave lens, applications of concave lens and the lens formula, and we will see one problems by using this lens formula, right. So, in previous video session we have discussed what is the lens and the type of lens. There are two types, concave lens and the convex lens. Then how the image formed by using convex lens, then applications of convex lens we are discussed in that video session. Today I am going to start the refraction through a convex lens, right. We know very well the shape of the concave lens. The center point is thin than the edges, right. So, the first topic is refraction through a concave lens. The first position, object at infinity. So, see my dears, this is the concave lens. The center point is thinner compared to that edge, right. Okay. So, here we have one principal axis. The center point, this is optic center, I take O, right. Then the focal length, this is a focal length F1 and 2F1. This one is focal length 2 F2, then this is 2F2, right. My first case is what? We have to place that object at infinity, right. If the object placed at infinity means the light coming from that object, it is parallel to that principal axis, parallel to that line, right. Now, the incident light coming from that object, this is a parallel line. These are incident lights. So, it's parallel lines. After refraction, it will passing through focus. Actually, the concave lens is diverging lens, right. So, the light is diverged from the center point. This is the diverging lines. Yes, all it will be diverges. But when you join and retrace this ray, it will meet at focus. All the lines it will meet at focus, right. So, see here the image will be formed. The first case, object at infinity means, so after refraction the image will be formed at focus. In this point the size is very small size. The nature of the image is virtual image. This is not real and inverted, this is a virtual image. See the position at focus. Second one, the size of this image is small size and the nature of this image is virtual and erect. This is our first case. Next, an object anywhere on the principal axis at finite distance. Okay. So, here finite distance mean we can place the object here anywhere at 2F1 or F1, okay, or between 2F1 and F1. Now, I place this object between 2F1 and F1, right. See my dears, now I place the object between f and 2f, this is the object, right? Here the two lines is coming from this object. One is the parallel lines to the principal axis, right? And the one more line, it will passing through optic center, right? So this is the optic center lines, it will passing through optic center. We already studied the two rules. If the ray passing through optic center means there is no refraction and no reflection, yes, and if the lines is parallel to the principal axis means it will be passing through focus. Now I am using this two rule, right? So here this line is not reflected and not refracted, so this is an incident ray, and this one is a refracted, but here not refracted and reflection, right? So here the ray diverges, yes, but when you extend this line passing through focus, this line passing through where? Focus, right? See my dears, here the two lines are meeting in this point. Here the image is formed. This is the image, yes, the position of this image between F1 and O, okay. Then the size of this image is very small size compared to this object, okay, and the nature of this image is what? Very good, virtual image. This is a virtual image, right? So today we seen only that two position, okay. For that concave lens we have only two position. First one is when object placed at infinity, the image will form. At focus, the size of image is point size, and the what? Nature of the image is virtual and erect. Here the second point, when object placed in anywhere, but the what? The distance is finite distance. If take this finite distance means the image will form in the same side, that's why we will get a virtual and erect image. Suppose when I move this object, close this lens, so that time the size of this image small, lightly increases, okay, right? Suppose this same object if I place here, right? So this position it may be changed. What position? The passing through optic center is changes. So here the two lines meeting and this point, so we will get what? The image, but this compared to this image the size is increases. Suppose when I move here, this is an object. If I take this object means, so position it will be increases. What position? Image position, right? Okay my dears. Next we will see the applications of lens, right? Applications of concave lens. The very importance of this applications is one of this Galilean telescope. In that Galilean telescope we are using eyepiece. This eyepiece is nothing but a concave lens, okay, but this is a convex lens, but that one is a what? Concave lens. So this concave lens we are using Galilean telescope in only eyepiece, right? Then the next application, see, this is our human eye. In our human eye, so many defects are produced. So one of the defect is myopia. In that myopia, this parallel lines after converging, it's not fall on this retina. That's why the image we cannot see clearly. Okay, how to rectify this what? Error. So we can rectify this error by using concave lens. Here I am using this concave lens. So, the concave lens we can say also what? Diverging lens, right. Here this parallel rays it will be diverged, then converging by using our eye lens, it will be what? Fall on this retina. When you apply the suitable focal length and suitable distance of what? Concave lens, we can rectify this error, right. Next, the one more application is the spy hole in doors. We are well known about this application. Okay. So many homes we are using what? This spy hole lens, right. But in this we are using what type of lens? Means concave lens are using. So, in this concave lens we can see that the diverged image, right. So, these are applications of concave lens. Okay. Then lens formula, this is very important. Lens formula, the lens formula is 1 by f is equal to 1 by v minus 1 by u. Here f is nothing but focal length, right. Then v is nothing but image distance, then u is nothing but object distance, right. Okay. How we can measure this f, v and u? See, suppose I take the concave lens or convex lens. Here I am taking what type of lens? Convex. This is the optic center f to f. The f, the focal length is nothing but the distance between the focus and optic center. This is the what? Focal length f, right. Next u, u is nothing but object distance. So, the distance between the object and the center of the lens, which means what? Optic center. So, this distance is nothing but object distance. This is u. Next, image distance. Suppose the image form here means, so this is the image means the distance between O and this image is V. Okay. So, this image, the distance it will be varying depends upon the position of object, right. So, image distance is nothing but the distance between the image and the optic center of the lens. Clear, my dears? Okay. Next, by using this formula, we have to see one important problem. Okay, right. See, here one problem is given. A beam of light passing through a diverging lens. Diverging lens is nothing but what type of lens? Very good. Concave lens. The length, the focal length is 3 meter, appears to be focused at distance 2 meter behind the lens. Find the position of the object. Find the position. Okay. So, here the what are the given data is given, focal length f is given and what? Focus at that distance 2m. So, image is given, right, u is unknown. So, given data first f is given, f is equal to 3 meter. So, we should take negative value minus 3 meter. Yes. then the image is V is equal to minus 2 meter. U is unknown value. U unknown value. Why we are taking this negative values? See, already I said, suppose the lens means or here given diverging lens. So, you take diverging lens. So, this is a diverging lens. Here object placed in left of this side. If you place this left of side means we have to take negative. Okay. And image, if the image is formed the same side of this lens means you should take negative. Why? Because we know that, so this is a x axis, this is a minus x axis or x dash. So, in vector form means this is I cap minus I cap, right. So, we have to place always the object in the left of this lens, that is why we should take negatives value, right. Okay. Now, you substitute the formula. The formula 1 by f is equal to 1 by v minus 1 by u, right. But the 1 by u is unknown value. So, 1 by f minus 1 by v is equal to minus 1 by u, or you can take 1 by u is equal to, very good, minus 1 by f minus of 1 by v. So, 1 by f is equal to plus 1 by f is equal to minus 3. So, minus 3 then plus 1 by minus 2, right. So, here also minus. So, minus into minus is plus. So, 1 by u is equal to 3 2s are 6, then 2 minus 3, 2 minus 3 is equal to minus 1 by 6. So, this is the 1 by u. So, u is equal to minus 6 meter. Yes, see here the given data, f is equal to minus 3 meter and v is equal to minus 2 meter, u is unknown. By using that focal length formula or this lens formula, 1 by f is equal to 1 by v minus 1 by u. When you substitute this, we will get u answer, right. Okay, my dear children, today we have seen what is the concave lens and how the image formation by using this concave lens. Then we discussed applications, okay. Then lens formula. By using this lens formula, we have discussed one problem. Okay. Okay, my dears, I have attached study material, question bank, self-assessment test, okay, in my description. So, please go through this study material and write the self-assessment test. Okay, thank you, my dears. We will meet our next video session.